Now, as for notes this year, as you guys know, I'm going to post everything to Edline. Actually, I'm going to post everything to Schoology. I will post it there. There's a spot I can post files to. You'll find it. Yeah.
How?
I can do it. Okay. So if you want to just sit back and relax and take it all in, then that's fine. This is something though that you probably should actually write out. One of the goals, one of the outcomes of grade 12 physics is formula derivations. Okay. And I will tell you that I will ask you one of these questions as a bonus on the test. Can you derive this formula? But really, all the outcome really is that you have seen some formula derivations, because in university, you're going to be seeing lots of them. Okay? So I'm going to now give you 3 new formulas. It's pretty exciting. You remember all those kinematics formulas from grade 11? And sometimes the steps were kind of long. Well, I'm going to make things a whole lot simpler for you. Okay? A whole lot simpler. Equation number 1, the simplest one. We'll start simple. You remember A equals delta V over delta T? In fact, this one is so simple that most of you are already doing it. Okay? Delta V is simply change in velocity, right? VF minus VI?
Yes.
Right? So all I'm going to do is I'm going to take this bit right here, and I'm going to plug it into there for delta V, and I'm going to get A equals VF minus VI all over, and I'm just going to leave out the delta on the T. Most of the time, your initial time is equal to 0, right? So like delta T, like do we need to write minus 0 all the time? No. So most times you'll see it with the delta in there, but a lot of books just sort of ignore it. And I'm just going to rearrange that. I'm going to write AT is equal to VF minus VI. Take the VI to the other side, and you end up with the final velocity is the initial velocity plus the acceleration multiplied by the time. And if you sort of stop and think about it, it kind of makes sense. That's kind of easy. The final velocity is whatever you started with plus whatever increase in speed you had, which was the acceleration times the time, right? In that example with the car and the truck, right? The initial velocity was 0. The acceleration was 3. We did it for 5 seconds. 3 times 5 is 15. Add that onto the 0, you get your 15, right? Or the 15 is 65, same thing. If you stop and you think about it, it's going to make sense. They're not all that easy. They're not. We'll now be moving to the shallow end of the pool. Equation number 2. All right.
We're living in a little time.
Okay. I'm going to draw a trapezoid. Do you guys know what a trapezoid is?
I think so.
Trapezoid usually looks like this, right? Right? But
What's the one where it's like a square? It's like
rhombus. A trapezoid can also look like that. Okay? Do you see the trapezoid? No? If I drew this in blue right there, do you see it? It's the same as this, but like that. Okay? Trapezoids generally look like this, but they could also look like one side that's sort of like that, flat. Okay? Does anyone, on the off chance, happen to know what the area of a trapezoid is, the formula?
Oh, there's 2 formulas.
You could, square plus triangle, yeah. Okay. Let me just talk about this in the sense of a velocity time graph. Cody, do you remember how to find displacement on a velocity time graph? No, I know that's a tough question. So Jordan might, because we just finished it, right?
Find the area.
Find the area, right? So we are talking about this area in here. Don't shade it in, by the way, because I'm going to be drawing in there. Okay, we're going to be talking about that area right in there. Okay, so I'm going to call this spot right here. I'm going to put this in red. I'm going to call that T1. I'm going to call that T2. Right, time 1 and time 2. And the velocities I'm going to call right here. I'm talking about these 2 points right there, by the way. This point here is going to be VI, or V1, I guess. VI, same thing. And this point here is going to be VF, or V2. How do I find the area of a trapezoid? recall that displacement equals the area under the VT graph. Displacement is the area under the VT graph. And in this case, it is the area of a trapezoid. Okay, no one's Googled up the area of a trapezoid yet on their phone?
Would it be VF plus VI divided by 2 multiplied by time final minus calculation?
Say that again?
Velocity final plus velocity initial, the average of that plus velocity final.
You're pretty close there, Jordan, I think. Zach's going to come up with the area of a trapezoid for us. He's just texting? He's far too curious, I know. I know he's doing it. Although I like how he's still hiding the phone from me, even though I've asked him to do it. Who needs an iPhone when you've got iBennett? I'm wrong. It's side 1 plus side 2 divided by 2 times height. In terms of a trapezoid, what that means is side 1, side 2, and this is the height. So basically all you do is you just take those angle sides and you just sort of flatten it out so it's a rectangle. Okay, and as you flatten this one, then it pokes that end out kind of. So you average those two heights. Now because I've rotated it, side 1 and side 2 are, this is my side 1 and this is my side 2, which are exactly equal to VI and VF. Okay, so awesome. So my displacement is side 1 plus side 2, which is VI plus VF over 2. And my height of my trapezoid is actually that distance there, right? Which is the difference between T1 and T2, which we know as delta T, right? Now, this particular formula, we could use it just like that, by the way. Really, if you look at that, that is just simply a rewrite of D equals V bar T, is it not? Isn't that all that is? Average of velocity times T? Isn't it? Right? Okay, now what I'm going to do is I'm going to do something crazy. I'm going to take VF from equation number 1, and I'm going to put it in there. Replace VF with VI plus AT. Now, why are we going to do that? You remember how I always harped at you over and over and over and over again? If you want to know the displacement, you have to know the average velocity. Remember how that was always a pain? Okay, well, guess what? D equals VI plus, and I'm going to put it in red for you. VF from before was VI plus AT over 2 times delta T. Does that make sense to you? Aren't you glad you got some math algebra skills? No? Does that make sense to you? I'll pause, yeah. What happens now? VI plus VI is 2VI plus AT all over 2, and that's all multiplied by, and I'm just going to ignore the delta again, by T. And now I'm going to do one last simplification. 2VI divided by 2 is AT divided by 2 is simply 1/2 AT. And if I multiply everything by T, then I put a T there and a T there, and T times T is T squared. Wait till the third one. That's just a shallow end. Yeah, it is. It's just a skill that you just need to see it. You need to be comfortable seeing it. So the displacement of an object that accelerates is VIT plus 1/2 AT squared. Now, if you'll look closely and you think here, D equals VIT plus 1/2 AT squared. I've said it 1,000 times. If the acceleration of an object is 0, if it's moving at a constant velocity, what falls out? The whole second part, exactly. And I'm just going to cover that up if I can. No, I can't. Okay, but so what's on the left-hand side? Just V times T. Is that not the same as That? This formula is really this one, just without the acceleration part. This is the acceleration part. This is the distance it travels because of acceleration. This is the distance it travels because it's already moving. Now, Stefan, what if it's starting from rest? What falls off? If the initial velocity is 0, then that part disappears, right? So if either one of those... Well, if the initial velocity was 0, it doesn't matter how much time it is, it's still going to be 0 times whatever, right? It'll still be 0.
Is that still delta t though? Or
That is technically a delta t, yes. It is.
would be the same for both of them?
Yep, yeah. But technically delta t, although... That's right. It's just half AT squared.
Okay.
Okay? Yeah? Good? So what that allows you to do is, if you know the initial velocity and it's accelerating, you don't have to figure out the final, you don't have to figure out the average. We've blended it all together by doing these steps. Now, there's no way grade 11s can follow that. Their brain would have exploded by now, right?
Hey.
You know what I mean. You've been through grade 11, man. You're good. You're like an honorary grade 12 student.
Sure, yeah.
You still haven't finished grade 11 physics?
No, it's like correspondence. I gave up on it.
Oh, God.
Where the hell are you going now?
All right.
Ecology?
Take equation 1 and isolate t. This is going to blow your mind away, but you're going to feel good about it when it's all done. Take equation 1, take Earl, equation 1, and isolate t. So, VF equals VI plus AT. Can you isolate t in your head? Can you manipulate stuff? VF equals VI plus AT. How do I get the VI to the other side? VF minus VI, and then divide by A, right? Isolate for t. Awesome. Now, put into equation number 2. Can I come up with a formula that doesn't involve time? So I'm going to replace the time in equation 2 with something that doesn't have time in it. I'll put equation 2 for you here in blue, which was d equals VIT plus 1/2 AT squared. And right away you should be getting afraid. How come? Because we're going to take this fraction, we're going to plug it in there, and we're going to plug it in there, and we're going to square it. But trust me, it all works out at the end. It's like a rite of passage. Oh, yeah. It's a rite of passage. If you can get through this, you're good. Here we go. I'll do it in blue. Leave lots of room. Big fractions coming. D equals VI. Now, in black, the T is VF minus VI all over A. Back to blue. Plus 1/2 A, back to black, VF minus VI all over A, and that's going to be squared. Okay. All right. D equals VI. Now, when I multiply that, that's going to be, can I just go all black now? Yeah, okay. So VI times VF is going to be VI dF. VI times minus VI is going to be minus VI squared, and that's all going to be all over A. Plus, now can I take the 1/2 A and just write that as A over 2? Good with that? Okay, now do you guys know how to square a binomial like that? They used to teach it in grade 10 math. Can you take x plus y and square it? How do they teach you that now? Right. It's the middle. It's the first one squared, the last one squared, and then the middle 2 times 2, right? The x and the y times 2.
Yeah, Ray says like the first one squared,
Yeah.
last one squared, and then everything just times.
Everything times together.
2x.
All with the 2. Okay, so what's it going to be here then?
So x squared plus.
Well, but not x, VF.
Oh, squared. VF squared.
VF squared.
Subtract 2, -2,
Now, here I wrote it as VIVF. Should I write it the same thing way? Probably, right? Because that, so VIVF, and then plus VI squared, and that's all going to be over A squared. Mary, has your head exploded yet? All right. Now, do you get a feeling of what we have to do next?
Simplify.
I got an A on the bottom on the left. I got a 2 and an A squared. When you add fractions, they have to be same denominator, right?
But there's A on top of the equation bottom, so you can count.
Aha. Okay. So Stefan sees that this A and one of those A's will cancel. Can I show it a cancel like that? Okay. So now this is just sort of a reorganizing, sort of refocus step here. D equals VI VF minus VI squared all over A plus VF squared minus 2VI VF plus VI squared all over 2A. Okay. When you add fractions, the denominators have to be the same. All right, mathematicians, what do I do next?
Simplify.
I got to make the left side denominator equal to 2A, right? Make them both the same. So can I just do this? Can I just put a big multiply, which means basically multiply the bottom by 2 and now when I put that 2 there, I'm talking about the whole thing, right? Okay, so it's going to be D equals big giant fraction all over 2A, and it's going to be 2VI VF minus 2VI squared plus VF squared minus 2VI VF plus VI squared. Oh, Mr. Bennett, this had better be good when you get to the end. Okay, so we're into canceling here. Those guys go away. I've got a minus VI squared and a plus VI squared. So altogether, I think I get D equals all over 2A. I got it. Let's put the VF squared because it's a positive, right? So VF squared, I got a minus 2 VI squared and a plus VI squared. That doesn't look so bad, does it? In fact, what we normally do is we normally write it like this. I bring the 2AD up here because nobody likes fractions in their formulas if you can avoid it. And most people like to write it like this. The final velocity squared is the initial velocity squared plus 2AD. See, that wasn't so bad, was it? So now you've got a formula that can tell you how fast something is going after it accelerates over a certain distance. You don't have to have the time. You don't have to have the time. There's no time in there. Well, if you're trying to find out how fast it's going at the end, or if you're trying to find out how far it's gone if you know how fast it's going and how fast it's going, right? How did I get rid of time? Interestingly enough, I got rid of time by substituting for time, and that eliminated the time. All I really did was I substituted for time here, and then I now this is really, you remember you guys did systems of equations?
Yeah.
Like things like this. Can I go to another new page here? I'll come back. I'll come back. Remember when you did stuff like this, x plus y equals 10, and x minus y equals 5, something like that? Remember doing things like that? Okay, and you know one of the strategies is to substitute, right? Like x equals 5 plus y, and you do this, right? And you substitute in there. That is exactly what we just did.
But really complicated.
That's exactly. But that's exactly what we just did. We isolated for t, right? I had this equation here, VF equals VI plus AT, and I had the second one that have 2 times in them. I isolated, I substituted for t, and I got an answer. It's an application of a system of equations. That's exactly what it is. See, that wasn't so bad. Now, one last thing to remind you of before we move on. I can get rid of this here. Everybody loves this formula, right? I'm not going to derive this one because you don't want to see it. but everybody knows x equals everybody knows this, right? Is that new to anyone in here? When what do the A, B, and C stand for? Ax squared plus bx plus c equals 0, right? Okay, so what we will have quadratics. It tends to happen when you've got projectile motion or people trying to catch buses and stuff like that. You get quadratics. So you're generally solving for time. So this x quite often becomes the time. Okay, so just a reminder of that one. I'm not going to derive that for you. Have you seen the derivation of the quadratic formula? Or did they just give it to you? You seen it?
I've seen it. I've done it.
So what is this?
Quadratic formula? Have you seen it, Zoe? No?
I'm in grade 11.
I know. Oh, you're in grade 11 math right now.
Do it with
Okay. I will. I'll come by and just give you a quick what the heck that is.
It's like showing the ending.
I'm just going to give it to them. Well, I'll do it right now, right? All that is when you've got a quadratic graph, right? And you're solving for, what are those points called? X-intercepts are zeros, right? You use, this is the graph or the equation of the red graph. You use this to solve for those zeros. X equals minus b plus or minus square root b squared minus 4ac all over 2a, where a is the number in front of the x squared, b is the number in front of the x, and c is the number by itself.
That's a plus or a negative?
Yeah, it's actually plus, yeah. There's actually two values, right? Because there's this one here, and there's this one here. So it's, you have to do actually both. You have to add and subtract because there's two answers. Interestingly enough, in physics, because you can't go back in time, you can't have negative time, we tend to ignore that one because it doesn't really exist.
We don't do the negative one?
Well, it's not always the negative one. It depends on what the other numbers are too. You got to figure out which one's going to give you a positive value overall. With experience, you'll figure out which one is the one. Yeah.
Okay.
When it comes up, I'll point it out to you guys.
Okay.
It won't be a problem.